Welcome to my channel Physics in Hand. Today I am going to discuss the topic atoms, higher secondary, second year, lecture number 3. The most important and interesting topic, atom. Here we will deal with some of the important aspect on the structure of atom. Maximum of you know the structure of atom more or less in details, but today I am going to tell you some important facts regarding the structure of atom. Actually, many of the chemists or physicists has already given a lots of theory or postulate regarding the structures of atom. Very fast we will discuss Thomsons model. This is introductory. I will not go in detail of this one. Simple, the fact is that the positive charges of atom are uniformly distributed and electrons are embedded in it, just like watermelon seed. So, this is a very preliminary idea, and this idea exists and continued till 1911, and the later on the concept was not found a truthful one, a reliable one, because a lots of factors of the atomic structure could not be explained by Thomson's model. Hence, later on, a lot of other scientist has proposed the structure. The first drawback is that it cannot explain the spectra, cannot explain the spectra or spectral lines in an atom. Number one. Number two, cannot explain the scattering angle. That is, when alpha particle is scattered in the atom, it deviates with some angle. The reason of the scattering of the alpha particle cannot be explained by Thomson's model. Thereby, later on, the alpha particle scattering experiment was come in force. It was a very important model and was given by Rutherford. Along with the experimental setup was done by Rutherford along of his two associates, Giger and Marsden, and they gave a lot of valuable information regarding the structure of atom. Though later on this model of Rutherford model of atom again come to be a futile one, a fruitless one. Then came Bohr. Later on again Bohr was failed in explaining some of the important factors regarding the structures of atom. Then Bohr-Sommerfeld model. That's why a lots of proposal or postulates of the atom come forward. Am I right? So let us first explain the experiment. So before starting with the experiment, let us first tell what is alpha particle. Alpha particle is twice helium, mass number is 4, and its charge is twice positive. This alpha particle may be taken from bismuth. Am I right? And this alpha particle is made to fall upon the gold foil. Gold foil of thickness, very thin gold foil. And Rutherford, along with his two associates, made the experiment and he observed some of the facts. Depending upon his observation, he gave some info. What's happened? Let me explain in details. Just I am showing you, this is gold foil of the thickness of order 2.1 into 10 to the power minus 7 m. When alpha particle is the positive charge particle made to fall upon the gold foil of thickness 2 into 1 into 10 to the power minus 7. So these are the observations. What is the observations? First observation is maximum of the alpha particle pass straight to the gold foil. He observed three observations. First of all, maximum of the alpha particle pass straight to the gold foil. Number two, some of the alpha particles deviates with angle 90 degree or greater than 90 degree, and very few, one or two alpha particle retrace back to its original path. Say these are the some particle who passes to the gold foil without any deviation, and some of the alpha particle deviates with some angle, and some of the alpha particle deviates with greater angle. Likewise, this. And some of that alpha particle, what's happened? The path it has come to this point, again it retraces back to its original path. Depending upon this observation, he drew some information, and these are called conclusion or inferences. First inferences is alpha particle pass straight means maximum of the space inside the atom is empty. That's why maximum of the alpha particle pass straight, because the space inside the atom is empty. Maximum space of atom is empty. Number two, so very important observation. First observations, once again, alpha particle pass state, maximum alpha particle pass state means inside the atom maximum space of atom is empty, and the sum of the alpha particle deviates with some angles 90 or greater than 90 means there are somewhere in the center positive charges, and alpha particle again is positive, there is a repulsion, hence it's deviate with some angle. And third one, and that alpha positive charge particle is concentrated at the center, and that center is termed later on as nucleus. And the last one is atom as a whole is neutral, that is positive and negative charge are the same. So these are the some observations and interference came out of the experiment, alpha particle scattering experiment in the gold foil. Now, interesting fact we can come across here is let me first define what is distance of closest approach. Means when alpha particle is passed in such a way that it faces the nucleus, that is center. At this point, before reaching the point, at certain point before the center of the atom, the speed of the alpha particle becomes 0, or the speed slowed down, or alpha particle stops. At that point, if alpha particle stops here, so from center to this, the distance is called R naught, is distance of closest approach. The alpha particle, when approaches the nucleus directly, at certain point the speed of alpha particle becomes 0, or alpha particle stops and start retracing back. Then this distance from where it stops and the nucleus is called R naught, and that R naught is called distance of closest approach. So at this distance, theta is equal to 180 degree. There is no theta, 180 degree theta. Where it starts, again it retreats back. Theta is equal to 180 degree. And at this point, when kinetic energy of the alpha particle stops, means velocity becomes 0, then kinetic energy at this position becomes or converted into potential energy. No kinetic energy is there, so it takes a position. So when a particle takes is as a position, then it is potential energy. When a particle moves, it is kinetic energy. When kinetic energy stops, means movement of electron velocity stops, that is alpha particle stops, that is kinetic energy becomes 0, then that point the kinetic energy become potential energy. Here there is a position, the position gives you potential energy and velocity gives you the kinetic energy. When kinetic energy equally transforms into potential energy, at that point theta is equal to 0 and kinetic energy is converted into potential energy. So at distance of closest approach, the kinetic energy totally converts into potential energy, and theta is equal to 180 degree centigrade. Now that closest approach is inversely proportional to K, means kinetic energy. If kinetic energy is more, closest approach is less. If kinetic energy is less, closest approach, distance of closest approach is more. Am I right? This is in simple distance of closest approach, and we can derive it how, but you yourself can do it very easily, because kinetic energy is equal to half mv square and potential energy, kinetic energy is equal to half mv square and potential energy is equal to ZEE by r square. When you equate these two, you will get energy is equal to r, and that r is equal to, you here assume r naught, then that r naught you derive, equate these two, kinetic energy half mv square, potential energy is equal to ZEE, means the charge of nucleus equal to Z into E, and the charge of another particle is equal to E, ZEE R naught. So you, on comparing these two, will get R naught equal to 4K Z square by K. R naught is proportional to 1 by K. Sometimes, very often in entrance exam and class exam, you are asked a relation between closest distance of closest approach and the kinetic energy, and from this you can derive this one. The condition is that kinetic energy totally converted into potential energy at this distance, r equal to r naught distance, and theta is equal to 180, means at this point where the alpha particle starts from where it retreats back to its original position. This distance is called distance of closest approach. Another important factor, very often question is asked from this point. Now, minutely follow. This is very interesting one. Impact parameter. It is very important factor. Impact parameter. It is designated by small b. Now, what is impact parameter? Now, what is impact parameter? You see, when a projectile is bombarded, when it moves, when it fall upon the atom, that is alpha, say alpha particle. When alpha particle is made to fall upon the atom, what's happened? It starts to move in this way, and before touching to the nucleus, it deviates due to the repulsion of positive charge and positive charge repulsion. It deviates. It doesn't go in the straight line. If you assume this projectile as straight line, say that angle is the angle of deviation, and that distance, it is a perpendicular distance from the velocity vector of alpha particle or a projectile from the center and the velocity vector, and that distance is called impact parameter. Am I right? So impact parameter is defined as the perpendicular distance of alpha particle velocity vector and the center of the nucleus. Alpha particle velocity vector and the center of the nucleus. That perpendicular distance is called impact parameter. Now, what is its significance? Significance is very important, very often asked questions from this. Now, let us explain what is the significance of impact parameter. If b is small, if the distance of b is small, means the projectile is very, very close to the nucleus. So, more the close of alpha particle plus positive particle towards the nucleus, in the nucleus, more is the repulsion, more is the deviation. So, b is small, deviation angle is more, means it will deviate it with greater angle. Am I right? Number two, b is large. If b is more, something more than this, if it is small, then it is very close to the nucleus. More is the repulsion of the positive charge of the nucleus and alpha particle, and there will be more deviations. And if b is bigger, so the repulsion of positive charge and alpha particle is less, angle of deviation is less. Deviation is less. And if b is 0, if the impact parameter, the distance b is 0, that means theta is equal to 180, it will retrace back. Alpha particle retrace back. Now, if b is bigger and bigger and bigger, infinity, means the rays pass undeviated, without deviation. More and more of distance of b, less and less of repulsion between the nucleus and that projectile alpha particle. So there will be less and less deviation, means maximum of the alpha particle is passed straight without any deviation. Means if b is infinity, distance is infinity, theta is equal to 0, there is no deviation, means all the rays will pass without deviation if b is infinity. These are the most some 4 parameters with the help of which we can explain the nature of the scattering or angle of scattering, or along with this we can tell about the internal structure of the atom with the help of impact parameter. Am I right? This is very, very important from exam point of view. Now, let us come to the drawback. Drawback of Rutherford atomic model. Number one, let me explain first. According to classical physics or electromagnetic theory, when a charged particle is made to revolve around circular path under the influence of another charged particle in the center, then revolving charged particle will deviate or radiate some amount of energy, it will lose some amount of energy, and thereby the path of revolution will decrease and decrease and decrease, and the deviating or releasing electron which is revolving in a circular path will lose electron and come closer to the nucleus, and the losing of energy is a continuous. So it will give a continuous spectra. It should have given a continuous spectra, but in actual practice later on we will tell that it will not show continuous spectra, it shows line spectra. This is one of the drawbacks. Means when according to the classical physics or electromagnetic theory, a charged particle when circulates in a circular path, it's lose out some amount of energy, and during the course of its movement, the orbital will come closer and closer to the nucleus. At a time will come when it will fall to the nucleus, so atom will collapse. So it can, but in actual practice we see no atom is collapsing, atom exists in its state, means it cannot explain stability of atom. The electron should have fallen in the nucleus within a fraction of this second, but no such things is happening, means atom is existing. So why atom is existing and what is the stability reason behind the stability of the atom cannot be explained by Rutherford. Hence it is one of the important drawback of this one. So if a charged particle revolves around the nucleus, it radiates some amount of energy, and if the energy of losing energy is a continuous, so it should have shown continuous spectra, but in actual practice it shows line spectra. That cannot be explained by Rutherford. Last one but not the least is that it cannot even explain simplest hydrogen spectrum. Why there is spectra is shown in the hydrogen cannot be explained by Rutherford. These are the some drawback which was unable by board to explain. First one is it cannot explain the stability of the atom. I have explained it in details. And second one is that it should have shown the electron should have shown the continuous spectra, but actually it shows line spectra. And number three, even cannot explain the simplest hydrogen spectra. These are some drawbacks very often asked in your class exam. So minutely keep it in your mind. No need to learn by heart, just simply you keep it in your mind. You can answer. I hope you can answer. So now if you now draw the scattering angle versus number of the particle passing in the atom, we see the graph is like this. Means when the angle of deviation is very small, there is no deviation, you see huge number of the particle is when the angle is this, angle, these are 10 degree, 20 degree, 30, 40, 50, 60, 70, 80, 90, 100 angle deviation. When angle is 10, 0 to 10, if you see, the angle is very small. When the angle is very small, means there is no deviation. So many and many more and more alpha particle is passing straight. Means when there is less deviation, the alpha particle pass straight. More and more alpha particle pass straight. And as we come forward, angle increases and angle increases. So when angle increases, the number of the particle deviated particles are less. So when the alpha particle coming closer and closer to the nucleus, so less and less number of the alpha particle is deviated. So this is the graph between n theta and theta. Now, Bohr's model. When there is failure of one model, then another model comes. When the failure of Bohr's model come, then Bohr-Sommerfeld come, though it is not in your scope of your syllabus. So till I am now explaining Bohr. What's happened to the Bohr? What Bohr tells? What are the postulate? Before starting the Bohr's model, let us first explain the one by one, let me explain, and I will efface out and I will write down another one. Postulates are very important and very often questions are asked in your entrance exams, also in the class exams, and lot of true and false statement or reasoning statements very often is given from these postulates of stationary states. Bohr tells that when electron rotates in a circular path or permissible path, you can write permissible orbit. When electron rotates in a permissible orbit, then it rotates without losing energy. Means these orbitals are having fixed amount of energy, and there is no question of losing electron when electron revolves in a circular path. And this explains why electron does not lose energy when revolves in a circular path, and that's why electron never falls on the nucleus. Number one. Number two is again very important. The centripetal force required for electron to revolve in a circular or permissible path is provided by electrostatic force of attraction between the electron and the nucleus. There are two types of things happening in this. Say it is nucleus. Nucleus is positively charged and electrons are revolving in this way. Velocity is v with this, and this is radius. Am I right? So when electron revolves, there what's happened? There one thing's happened, that to compel the electron to move in a circular path or around the nucleus, it needs some amount of energy, inward energy or radial energy towards the radius, towards the center, so that electron cannot escape out. That energy is called centripetal, and one is centrifugal. And if you cut this radius, this energy, then electron will move in a tangential manner, centripetal and centrifugal force. So the centripetal force, the energy which required the electron or make the electron bound to rotate in a circular path, that is inward attraction of the electron, centripetal force. That centripetal force comes from where? It comes from the electrostatic force of attraction between the electron and the nucleus. Nucleus is positive, electron is negative, so positive negative, there is attraction. Due to this attraction force, the energy is provided, and that energy is acted as like of centripetal force. Number three, is again very, very important. So you see, quantum condition. What does quantum condition means? I am not writing the explanation. I am telling you just to listen. It is very important and very essential. Only those electrons can rotate in a circular path around the nucleus, whose angular momentum is an integral multiple of h by twice pi. Angular momentum is L is equal to mvr is equal to n into h by twice pi, where n is the principal quantum number and value of n is equal to 1, 2, 3 dot dot dot. Not fractional value. What does it mean? Only those electrons can revolve in a circular path. Only those electrons can revolve in a circular path whose angular momentum is an integral multiple of h by twice pi. This is constant. This constant term should be multiplied by 1, 2, 3, not 1.2, 2.1, 2.3 or 1.29. No fractional value is allowed. If you give this fractional value, electron will no longer move in a circular path. That is, each and every orbit has a fixed level of energy. If electron wants to rotate in level 1, level 2 and level 3, the level 1, level 2, level 3 has a fixed amount of energy, and this energy is corresponding to the value of n 1 to 3, not fraction. Now question arises, if I put the value fraction, what's happened? Say electrons are moving in this way. So in a wave manner, electrons are moves. So if it starts moving in this way and it continues in this way, the phases are in the same manner, it continues in this way. So when the value of n is equal to 1, 2, 3, the wave, during the movement of the electron, the waves are in such a way that it continues. Now, as soon as you put the value 1.2 or some fraction in between 1 and 2, in between 2 and 3, now for that value, the angular momentum becomes something, and for that angular momentum, what's happened? The electrons moves in such a way that if it starts from this one, it ends in such a way that there is no continuation as earlier when n is equal to 1, 2, 3. If you put the value n 1 between 1 and 2, any fractional value, then these things will happen that electron will no longer remain in the orbital 1 or 2 or 3. That means the value of angular moment of electron must be integral multiple of constant term, not fractional multiple. If it is fractional multiple, that will be this. The situation will be this. Now you may tell n by h pi how we have come across this one. So if you talk about the circular path, so you get circumference. That this circumference equal to twice pi r, and this circumference into n into lambda, and we know lambda is equal to h by mv. Now if you put twice pi r is equal to n into h by mv, so we get mv. You take mv here, mvr is equal to n into h by twice pi. That is how we can derive mvr is equal to n into h by twice pi. Am I right? So these are very important, very often question. What is quantum condition of Bohr postulate? Is nothing but the angular momentum of the electron rotating in a circular path must be integral multiple of h by twice pi, not a fractional value of n. Third one is frequency condition. Now what is frequency condition? Now when electron moves in different energy level from the nucleus, what's happened? During its rotation in the circular path in E1 energy level E1, E2, E3 fixed energy level, electron may gain some amount of energy or electron may lose some amount of energy. Electron may absorb, electron may radiate energy. When it absorbs some amount of energy, it jumps from this energy level to higher energy level. Again, on releasing the same amount of energy which it absorbs earlier, it again comes back to its initial orbital. So, say E1 electron is in E1 level and it jumps to E2 level, higher energy level. So, the change of energy is nothing but E1 and E2, that is equal to del E, and that del E is nothing but H nu, Planck constant and nu, and that H nu equal to C by lambda, that is energy is inversely proportional to lambda. So we have seen that on absorptions of energy by electron from lower energy level to higher, it jumps from lower energy level to higher energy level, and consequently it rebounds back to its initial position by losing the amount of energy which it has absorbed, and that amount of energy is equal to H equal to Hc by lambda, and this lambda is related to the color, that's why it shows some amount of color, and that is called frequency condition of Bohr's postulate. Or you can write E of final minus E of initial. Same thing, you can write this one. Now let us try to derive the expression of radius with the help of Bohr's postulate. Mind that before that I am telling you the centripetal force required by an electron to move in a circular path is the amount of energy required for an electron to move in a circular path, mean centripetal force, is provided by the electrostatic force of attraction between electron and nucleus. That was one of the postulates given by Bohr. Now, what is centripetal force? Centripetal force is mv square by r. And now, what is electrostatic force of attraction? F is equal to k q1 q2 by is jd and e divided by r square. So, in a fixed path, when it starts revolving, means at that point centripetal force and force of attraction between the electron and the nucleus must be equal. So from this we get this mv square by r is equal to k jd square by r square, or mv square by is equal to k jd square by r. So we can give it 1. Very simple. You need not to learn anything by heart. Just you follow the technique. You can understand very easily. According to the postulates of another postulate of Bohr, we know MBR is equal to NH by twice pi. From that, if you take B is equal to NH by twice pi into MR. Now, if we put this value here, what we get is M into NH by twice pi MR whole square equal to KZ square by R. So that Now what we can cancel out this r, so we get am I right? So from this, if you find out r, then that r is equal to this is the expression of radius. R is equal to n h square by 4 pi square m k z e square. N is the principal quantum number, h is Planck's constant 6.12 10 to the minus 34 joule per Kelvin, 4 pi, 4 is constant, pi is the value is known to you, mass is known to you, k is the another constant is known to you, z is the atomic number also known to you, E is the charge of electron also 1.6 into 19 is also known to you. You put the value, you will get the answer. Now again, interesting fact here is that if you put n is equal to 1, that is first orbit, principal number n first orbit, and z is equal to 1. So what we get here is r naught is equal to a square by 4 pi square mk z square, and if you put the value, you will find that value is this. So this is the value of r naught Bohr radius for the innermost orbit when n is equal to 1 and z is equal to 1, and that is called Bohr's radius r naught equal to 0.53 angstrom. Therefore, Rn for any orbit 1, 2, 3, what will you do? We will put here n square into 0.53 angstrom. If it is 1, put here 1, 2, put here 2, 3, put here 3, you will get this value. So we have calculated the radius of the atom. Now speed of electron, very often question comes in entrance exams, also in class exam, in NCERT exam. This time also a question comes from this in NCERT course. So I am explaining, you minutely follow. This is very simple. We know it already from Bohr's postulate, MBR is equal to n by twice pi, and also from centripetal force and static force of attraction. We have balanced it. We have shown it mb square equal to z square by r. If you equate this to m into what is b square is b square and k z square, and what is r? R is equal to nh by twice pi mb, and twice pi mb will go up. Am I right? So that m and that m cancels out, b and b cancels out. What we get here is Interesting relation here. We see speed of the electron. We see that we have calculated this one, mv square r by equal to kz square by r square, and mv square equal to kz square by, I need not to explain it, I have already explained it during the derivation of the radius. And then mvr is equal to nh by twice by r is equal to this. We have just placed the value of this one equal to, we have got v is equal to twice by kz square by 1 by nh. For z is equal to 1, that is innermost orbit, the velocity of the electron, velocity or speed of the electron, we are calculating v is equal to twice by kz square by nh. So we have just taken a c, a term c here, and we have balanced it here. So this whole term is again a constant term, twice pi k e square c a. C is the velocity of light and h is the Planck constant. Everything is constant. We assume it is alpha, and that alpha is a dimensionless constant. And that alpha, when you calculate that value, you put the value twice pi k e, and c and h will get 1 by 37 c by n square. What we get here is, what relation we established here is, v is equal to 1 by 37 into c by n, means v, velocity of the electron in the first innermost orbit of an atom is 130 times of the speed of light in vacuum. Velocity of electron revolving in a circular path in the first innermost orbit is 137 times of the speed of the velocity of light in vacuum. One condition. And another is that the velocity of electron moves in the first orbit is inversely proportional to the principal quantum number. If n is equal to 1, it will, when the value of n increases, means second, third, fourth, fifth, the velocity will decrease. Am I right? So is inversely. We have drawn two interference. The velocity of the electron in the innermost orbit of an atom is 1 by 137th of the velocity of light in vacuum, and again this velocity is inversely proportional to the principal quantum number. This is all about the today's class. Hope you have find it very interesting, and kindly subscribe the channel and let others get the opportunity to watch the class. Allow others to subscribe. Physics in Hand by me, and it is lecture number 3, and bit by bit in next class I will explain a lots of example with entrance point of view in mind. Thanks a lot for watching the